Everybody. I'm going to go ahead and get started. There's still some more people we see signing in, so just giving it a couple minutes there to get people logged in. But we're going to go ahead and get started. Again, my name is Eric Adamai. I'm a senior project manager with Pond & Company. We're a full-service architecture and engineering firm that includes master and military planning and construction management division. I'm joined today by some of our team members from Mal Technology. Anthony, would you like to introduce your group?
I'm the sales director for the DoD sales team here at Owl Cyber Defense, and we're working with Eric and team in regards to synergies of how we talk about securing the areas of technology. Brian, you want to introduce yourself?
Hi, I'm Brian Romansky. I'm the Chief Innovation Officer at Owl Cyber Defense, responsible for new markets and new technologies.
All right. Thank you, Brian. So today we're here to talk about cybersecurity requirements, kind of UFC, federal DoD projects, and what's the requirements there, how we can help you with those projects, and just want to go through some of those high-level topics and talk also about the construction side and how those are implemented. All right. So cybersecurity requirements, why are they here? Why was the UFC created? And we want to look at considerations when designing all types of electronic control systems for federal and DoD buildings. In today's world, protecting these systems is critical for safety, security, and resiliency. The constant threat of cyber attacks has required all control and telecom systems to be protected from outside intruders. We will discuss how to plan for threats when developing project scopes, working through the design process to ensure cyber requirements are captured, and having these protections constructed and tested according to verify your facilities are protected and meet those requirements specifically in regards to this UFC. So why were the cybersecurity enhancements made? Current buildings have vulnerabilities due to increased requirements for remote monitoring and control of building systems. Common systems most buildings have are HVAC controls, fire alarm, electronic security systems, CCTV, and utility meters. These systems create a risk for intrusion from outside sources. So an executive order was signed in 2013 that requires federal agencies to protect building control systems similar to the level of the protection for standard IT systems. So buildings have long protected their IT systems, but again, some of the building systems I've already mentioned need that protection as well. And that's really where a lot of this UFC is driven to and kind of helps you understand what's required. For DoD projects and many federal agencies, following UFCs is a requirement. Knowing all the UFCs and their most recent versions is a tall order. So today we want to go through UFC 41006 to provide some background on why this is important and how you can implement it on your projects. Protecting building environmental controls. As discussed, most buildings have several types of control and automated systems today. As we become more digital and technology advances, these systems are connected to the internet where they can be monitored or controlled from a remote web-based interface. This convenience provides opportunity for people to access building systems. Once these people access a building through one system, they can gain access to other systems within that building, which drives why this was created and why the executive order was issued. Making sure projects are planned appropriately, designed accordingly, and constructed and tested to those standards are critical for protecting a building. So as you go through, and we'll talk about today, of how to protect your building from the cyber threat, not just on the physical side, but now the cyber side is important, and make sure you have it included in your project. So we'll kind of get in and talk a little more about those. The building systems we've already mentioned, fire alarm, intrusion detection, HVAC controls, are critical to the function, safety, security, and resiliency of a building. However, with these systems comes risk. These systems are routinely connected to the internet for remote monitoring or control, which provides the opportunity for unwanted outside access to the building systems and technology. To protect your buildings and their respective systems, creating a cybersecurity framework that includes a set of standards, methodologies, procedures, and processes that align building operations function, and technology is important in planning, designing, and constructing facilities to address these cyber risks. This process needs to start at the planning stage when initial scopes of work and 1391s are developed. Based on the mission and function of a building's users, a determination of how robust that cyber framework is required to be needs to be determined at that stage. This helps you account for cost early on and also the scope of what's going to be required as the project progresses through its life cycle of design and construction. Typically on projects that have SCIFs, ICD 705 requirements, or some specific user group requirements that a lot of facilities on DoD installations, federal agencies have these specific security requirements, a site security officer is part of that user group and also needs to be engaged on these conversations. On projects that do not have a site security officer, there's typically still a government stakeholder that can provide feedback for the requirements on a particular project. For DoD projects, the UFC does give points of contact for each military branch. So if a user group may not have that site security officer, there are resources you can reach out to on the government side to get who those contacts can be that can help you determine some of these risks. Making sure the right person is involved at the planning stage is crucial, because again, this is where you want to make sure you capture the cost and all the scope requirements that will be required for your project. So getting it involved early on can help prevent overruns later on. And it's always better to do these up front than it is later on during later design processes or even construction. So having all cybersecurity requirements accounted for during the planning stage will ensure you have accounted for the cost and scope of the project's cyber requirements. When planning for an upcoming project, understanding common vulnerabilities in systems can help you determine specific protections your project will require at a minimum. Systems that are network connected are required to be protected. This includes any equipment that has a network transceiver which is directly connected to the network and implements a network protocol. Be aware that a device connected to a non-IP network is still considered network connected. An IP connection or IP address is not required for a device to be network connected. When you go through, we'll talk about your architecture and how you lay this out in the RMF system, is you want to look at your level 1 and level 0 processes. Back to devices that are not IP connected or have an IP address. When you're laying out the architecture for this that we'll get into with the UFC, this is usually your level 0, level 1 devices, which are your sensors, your actuators, your controllers for those devices. So a lot of times they won't have an IP address, but you still need to make sure they're considered when you're going through this process and are protected. So just want to be clear on that point. Operational technology, or OT, open protocols, are common in building systems. These are the systems that control and monitor physical processes or equipment. These systems are intrusion detection, fire alarm, and utility meters. These are typically designated as OT systems. However, as technology continues to advance and the building systems become more digital and IP enabled, where these systems interface with web browsers, the systems become more of an IT system. A common example is utility meters. Currently, a lot of EMCS meters are on utility SCADA systems, especially on DoD installations. Some buildings also now put this on a BAS system, or that's where they are moving towards. Understanding how each respective building system is connected, where it's connected, and functions will determine the solution for protecting that system from cyber threats. So this is one example that UFCs require these smart meters be put on buildings. That's common on most of our projects that we design, and understanding how that's connected and where it's connected to, it'll help us determine the solution for you. So again, that's just one of the examples that are common on buildings, how we're going more to that network side. So understanding those is important. And again, if you have questions, we have the chat box opened up. If you type questions in during this, Brian's monitoring those, and we'll go over those at the end. So as questions pop up, feel free to insert those into the chat, and we'll get to those at the end, or send you an email with a response if we aren't able to get to those. Okay, We've gone through the why implementing these protections need to be included in your projects. Now let's get into applying the requirements on your projects. UFC 41006 Cybersecurity of Facility-Related Control Systems was first published in August 2016. Change 1 has since been issued, and that was on January 18, 2017. This is the current version of the UFC requirement. This is applicable to all planning, design and construction, renovation, and repair of new and existing facilities and installations that result in DoD real property assets, regardless of funding source. Implementing this UFC will require determining the impact the respective system can have on organizational mission using high, moderate, and low impact levels. This determination for the high, moderate, and low impact levels needs to be discussed with the system owner and authorizing official. The goal for determining the appropriate risk level is to reduce and mitigate vulnerabilities until the risk is acceptable to the system owner and authorizing official. Again, the system owner and authorizing official is on the government side. For design teams, consultants, we can provide recommendations and input. Ultimately, the decision lies with the system owner and authorizing official on the government side. Risk reduction is not an all or nothing process. It is a security solution to reduce risk while considering constraints of resources and mission requirements. So mitigation is a main concern when we're looking at what risk levels we're at. In project specifications, Division 25 integrated automation specifications outline the requirements for building systems. This division of specifications should be done in conjunction with other specification sections. So this Division 25 is newer to projects. We've been putting it on projects, but it does not replace any other specifications. It supplements those. So making sure that Division 25 is included in your project and how that integrates with your other specification sections is a critical piece of the project. An example that's a common specification we have on most projects that have HVAC is section 230900, instrumentation and control for HVAC units. This lists criteria and performance requirements for an HVAC system on a renovation new construction project. The Division 25 specification supplements that specification to include the cybersecurity requirements that the system must also meet. So again, 23 is going to go through how that performs, those performance requirements, but the cyber protection piece is going to be that Division 25. It needs to be make sure it's included because again, it's supplemental to Division 23. It's not exclusionary of 23. So the Division 25 specifications will provide the details and design for the contractor to meet, be able to make sure that they're in compliance with the UFC. So again, the Division 25 is going to lay out that criteria that the contractor has to meet, again, for their testing and design and construction portion. All right. Going through the UFC and following a 5-step process that's listed in the UFC can help you navigate through planning, designing, and constructing a project in compliance with this UFC 41006. We'll walk through each step listed in this UFC that describes the different stages of a project lifecycle to review where these are really applicable and at what stages. For planning, the goal is to make sure you have a clear understanding of scope and cost. Steps 1 and 2 in this process need to be done at this stage to clarify those items to make sure you've accurately captured the cost that's going to be associated with these protections and then the scope to make sure during the design stages it's understood what's going to be required. At the design stage, steps 1 and 2 should be verified as criteria, mission, and regulations can change between the planning stage and design stage. This is very common, especially with 1391 development, that planning takes place years before a project may be funded. So as these UFCs evolve, as the regulations evolve, as the mission for the user groups evolve, you want to make sure you're verifying that initial cost and scope that was done during the planning stage. In design stages, steps 3, 4, and 5 should be accounted for in the design documents. So the UFC does go through each design phase and what is expected during each of those design phase submittals. So this is going to go through steps 3, 4, and 5, and we'll walk through all of these here in a minute. I'm going to kind of tell you a little more detail about them. But during the design stage, all of these steps need to be done before a project is 100% designed. During the construction phase, step 5 is implemented and testing performed to validate all the requirements listed in these. During the design stage, we would recommend having a team that is very familiar with the construction side to verify the performance criteria is not overly vague or misses the mark for performance function. This can drive up schedule impacts, cost impacts, so having that team engaged early on is very important. This is where our design teams with Pond & Company work with OWL Technologies to develop design documents that are constructible and have been vetted to ensure compliance with the system owner, site security officer, and/or authorizing official. So again, we're not going to spec sole source things, because I know that's a big thing for Corps of Engineers and other federal agencies, but it's making sure that what we spec is clear and is constructible and is not vague to where you're going to come back with mods down the road. So having that team engaged, again, with the government side stakeholders, that's that authorizing official and system owner, is critical during that design development to make sure everything's accounted for. When you do have it go to construction, it's clear understanding of what is expected. Okay, so step 1. This is to determine the control systems and their impact rating, low, medium, or high. These are in regards to the confidentiality, integrity, and availability impact levels of the systems. So these are 3 categories: confidentiality, integrity, and availability, that have to be looked at for each of the building systems. This is determined by the system owner, authorizing official, and/or site security officer. The decision of whether a level of risk is acceptable is made by the assigned government authorizing official. The planners, designers, consultants will provide you input into the risk analysis process by advising on the impact or lack thereof of applying security controls to the control system. Do not proceed to the next step until this has been determined, as it dictates what is done for mitigation in the next steps. So understanding clearly what are the expectations of this system need to be done early in step 1 before you can go on and determine how to solve solutions. So before you determine the solution, you got to know what the problem is and what you have to meet. And that's what's done in step 1. All right, step 2. You want to compile a list of all the controls and systems that need cyber protection. Systems identified as moderate and high level impact systems generally will require a more expertise and custom design than the standard UFCs and whole building design guide specifications list. More standard systems that have low and moderate ratings can typically be handled with applicable UFCs and whole building design guide specifications. This is design specification 25 typically. Working with your planners and engineering team can help identify all applicable systems to verify they are accounted for. When the list of relevant controls is not provided by the service, determining a list of applicable controls based on the confidentiality, integrity, and availability impact ratings are provided in the UFC for the service branches or federal agencies. Again, they list in the UFC contacts, point of contacts that you have if you have questions on what's going to be applicable to you, but they also list in Appendix G and Appendix H some examples and give you a little more feedback of what would be required on typical projects for these low and moderate ratings. The DoD uses NIST SP 882 as an overlay to determine the starting baseline security controls for control systems. So if you're not familiar with this NIST SP 882, it's a document that gives you baselines for what's usually required on these low and moderate things. You are able, if you have CAC access, to gain access to this website page. We'll get to what that website is in a minute, but again, it's CAC-enabled website. So if you don't have a CAC, usually whoever your federal or DoD project manager is would have access to that, and they can send that out to the design team or to members that are, inquisitive on why or what's going to have to be required for their project to make sure it's incorporated. So we'll get to what that website is in a minute, but that's kind of what documents used as an overlay. All right, moving over to step 3. Step 3, using the latest list of security controls from step 2, so the list you've already created, create a list of corresponding control identifiers known as CCIs. This list will provide a starting point for identifying cybersecurity requirements to be included in the control system design. A complete CCI list is available on the RMF Knowledge Service website. Again, this website is the one I was referring to before. They can give you some examples and some background if you're unfamiliar with these requirements. That's rmfks.osd.mil. Again, it's a CAC-enabled website, so design teams without CAC would have to request the CCI list from the respective government project manager. Again, this is a great tool to use when going through your projects, to understanding what has to be protected, and then it can give you, tables that lay out what's going to be required for those. So this is a very good tool to use, especially if you have that CAC, you can go ahead and take a look at it. If not, you can request it from your government project managers. Again, that site is listed in the UFC. So if you have questions or want a quick link, go into UFC 41006. It's going to give you access to that website link. All right, step 4. This is categorizing the control correlation identifiers, the CCIs, by responsibility. Each CCI identified in step 3 requires classification into one or more of the following categories. 1, it can be DoD defined. This is either the DoD has provided or the DoD or federal agencies implementation guidance states the CCI has already been met by existing policy or regulation. So making sure that that's already done, you have to document that it's been defined and it's already been taken care of by an existing policy or regulation. Another one that can be used as a category is the designer. So these are in your projects when the design team needs to incorporate it into either an RFP for design build, design bid build, full design package. That needs to be the responsibility of the designer. Those ones need to be identified as being handled by the designer so everyone's clear. The third category things to be listed as are non-designer. These are typically system owner things. They are beyond the scope of the UFC. It's things the user group is usually going to handle themselves, and understanding that those have to be protected and maybe something has to be done during a design project to accommodate that just needs to be flushed out and where that line of demarcation is. So non-designer can be designated, but understanding who is then responsible still needs to be accounted for. A fourth thing is platform enclave. That's another category you can use, and it's a common example is passwords. This is where CCI will inherit these from another source and implement them in their process. So again, passwords are a common example of a platform enclave, but it's a category you can define where CCI is taken care of. And the last and fifth one is impractical. This is typically used where it's only applicable in a limited manner. It's not for the overall BAS, it's not for an overall system, it's specific to a certain instance that's going on, and that's where you'd list it as impractical. So those are the 5 you can do: DoD defined, designer, non-designer, platform enclave, and impractical. So again, these are listed in the UFC, but that's kind of where you need to go through step 4 and make sure it's really a roles and responsibilities matrix of who's required to do what, and make sure that there's a step for all those to make sure it's verified. And a design team's not saying, well, we think that's being handled outside the project. If it is, they need to identify who's doing that and how it's being taken care of. So just making sure everything's buttoned up and clean. So having that roles and responsibilities, that's really the main takeaway from step 4. Step 5 is incorporating cybersecurity requirements into project specifications. Each CCI shall be addressed in one or more of the following ways. 1 is you incorporate a design requirement into the specifications for the control system to do. 2, select the required changes to standard CCI requirements which affect CCI implementation. Or 3, provide information about the design to others so they can implement a CCI specifically. The CCIs as systems is expected to inherit from other systems or platform enclaves need to be listed here as well. These steps are further defined in the UFC and appendices provided with examples. And again, this last step is making sure everything's buttoned up and taken care of. So the systems that need to be protected, everything's accounted for, and no one can say, well, I thought so-and-so was doing it. This goes through those ways, and why step 5 has one of 3 ways that every CCI must be addressed by. So again, that implementation, this is really passing over from design to construction and making sure all of those have a method and solution to be addressed is really the goal on the last step of this process. And this is where it would transition over to construction and then testing. All right, an example project we want to go over, kind of a smaller project, but we wanted to have an example here to kind of talk through. This is a SCIF. Many buildings today have a SCIF in them, an ICD 705 enclosure, or an area that's more secure within the building. So UFC 41005 provides a lot of detail on physical security and sound mitigation, but determining the cyber security requirements of these spaces is just as critical for protection of information and systems. In this example, there were 4 main systems that required protection as part of our design package: HVAC controls, fire alarm and mass notification, electronic security system, and the information technology servers. Protecting these systems is mission critical, and the design was developed to provide the protection criteria required to meet the authorizing official's goals. We worked with the government stakeholders to develop a 15% level package for requests for funds. At this stage, we were able to identify line items to account for cybersecurity requirements on this project. This project went design, bid, build, and at each design submission, followed the UFC requirements for the deliverable of the project. The project met all the required security standards and was approved for construction by the authorizing official. The design team worked with the site security officer and the government representative that would certify the space during the design process. Following the UFC processes at the start made this project a success and ensured the user had a complete and functional facility at design completion. So this was turned over to them, turnkey. Project went well, and again, protecting those systems, identifying which systems needed protection early on, then who was responsible for those systems is what had to be done, and kind of walks through all 5 of those steps that we discussed earlier. To recap, everything we just kind of discussed, was going to review some of the key parts of the 5-step process. Step 1 is determining the systems that are needed to be protected. These are some of the common ones we reviewed today, listed here on the screen. So HVAC controls, intrusion detection, fire alarm mass notification systems. Most buildings today, most renovations we do, are going to have all of these systems on there, and they're going to need required protection. So understanding these systems, again, just some common examples here, is crucial to make sure it's captured at each stage from planning, design, construction. So in step 1, another critical thing, again, so before you can go to the next step, is determining that impact rating of the systems. Make sure the system owner is working with the authorizing official to determine the impact levels. Low and moderate levels can be captured with the UFC's and applicable whole building design guide specifications. Moderate and high levels will require addition, custom, and tailoring to meet those levels. So again, the UFCs, talk to a lot of standard building types, but again, when we start getting into federal DoD projects, you guys have unique SCIFs, unique secure spaces. Making sure those stakeholders are engaged early on will make sure that process goes smoother for you. So that's really the point of step 1, and why the UFC doesn't want you to go to step 2 until you kind of lay that out and get those people involved. So the example here has determined the confidentiality, integrity, and availability impact levels to be low for this building. So UFC 41006 directs us to use Appendix G and H of that UFC for requirements. Steps 3 and 4 are working with the CCIs developed and assigning responsible party and criteria. These appendices and the government's RMF website can provide the necessary information for laying these out. So again, this is just a small example, typical example we would list out for different systems in a building. So here we have an HVAC control system shown at the bottom of the screen. So loss of the confidentiality, loss of integrity, loss of availability of that system, the likelihood, the impact it would have on the mission, and then the risk level. Again, this is determined with that authorizing official and system owner for the project. All right, and last step is step 5, where implementing the requirements is done. The design team should clearly identify the performance criteria and responsible party. The contractor will then work with their subcontractor to provide detailed shop drawings and testing reports to meet the requirements. These need to be identified in your project specifications for the contractor to follow. Now, I'll pass it over to Anthony to discuss an example of implementing the protections we have been discussing.
Yes, so as Eric was describing there from a cybersecurity perspective, stage number 5 really talks about the different vulnerabilities that it can be assessed from a high or a low perspective. And what you're looking to do, and where OWL and POND come together, is the technology that can utilize the data diode architecture to utilize the zoning of digital access points to security. And when you look at the actual data that you're bringing into the building, and or the functional control systems that are being utilized at the building location, and physical access, that's where you need to look at those vulnerabilities. And those are the 3 that are listed here. And what we're going to show is a couple pictures that'll go through how our technology can be utilized for each of those elements. The OT element, which is really the operating capability of the building itself, but all fall under both the critical infrastructure for industrial control systems and or the classified network connectivity that we have. Next slide. So when we move through the absolute information control, we're looking at connection of the building to technology that's connected externally. Some of those things might be the HVAC control or fire detection and suppression. The access control panel to the building itself, and occupancy sensors and cameras or monitors. By allowing someone to have access to those systems, you can make a vulnerability threat to the building itself. And our technology, the OWL cyber defense technology, is really designed to help eliminate any outside connection and provide just a one-way transfer of that data in or out of the building. In this case, you only want secure connection into these types of systems. So remotely, there's no remote access to those type of capabilities or changes that can be applied. Next slide. This is an example of an OWL data diode that enables the external OT network or data transfer and monitoring without potential threat. By eliminating what you can do, the information control of those sensors, whether it be a sensor data collection or industrial control system, or even the access to the air conditioner unit. The fire protection alarms and events and things like that, throwing off a fake alarm could send a threat vector to the building itself. So the vulnerabilities from that perspective are very important. In the critical infrastructure marketplace that we serve to our customers today, we use appliances that are all-in-one appliances that can be used as a plug-and-play operation for data diode architecture. And this allows a one-way transfer of data without any back channelization or input from the other network. So this provides a secure network connection and can be used with multiple protocols and applications in the critical infrastructure and industrial control systems type applications, such as OPC, MQTT, file transfer, SNMP traps, and so forth down the line. You see them listed there. Next slide. So the next piece is really talking about physical access point to create the potential threat with portable media devices. And when we talk about portable media devices and digital devices, you're talking about when you enter these buildings. If you're familiar with the Department of Defense world, you are restricted to certain ways that you can gain access to those rooms. You're also restricted for what you can bring into those locations, such as a USB stick or a CD-ROM or something to that nature. And what you need to be aware of is the threat vector of those types of elements coming into the building. Because once you plug them into a CPU or into a computer or a workstation, you're then could possibly change what's happening there. Next slide. We have an appliance that's used that's called the OWL XD-Air, which is a portable media security kiosk, if you will, that prevents unauthorized and malicious media from entering. We use deep content inspection, which is DCI, a software-based capability that allows you to build a manifest based upon what would be on that CD-ROM or USB flash drive or SD card that you might be bringing into that location. So what this does is allows you to have some of that media, if allowed, and be able to cleanse that information to a gold disk or a gold USB stick. And what I mean by that is instead of me entering the building and allowing my USB to connect to that office location or sharing any information from my USB, I have one that can only be used within that building, and that can be cleansed prior to actually being connected to the network. It's very important to think about the vulnerabilities when you're bringing in media, especially into a technology center like this. Next slide. The next stage of absolute control is really talking about how those external network connectivities for high assurance controls and content filtering in accordance with security classified and classified network capabilities. When you talk about the server room or inside that SCIF, there's information that is in some cases staged as unclassified, some as classified, and some even as higher than classified, if you will, depending on what the level of the location is set for. Within those parameters, in order to share information between classified networks, we have something, a technology that's used as a cross-domain solution, which is certified by the NSA and is listed on the NCDSMO approved products list, that allows you to send information to and from one network to another via a one-way transfer, unidirectional or bidirectional in nature, in regards to getting information or obtaining information from one network. So by doing so, you're utilizing the hardware force data diode architecture within our cross-domain solutions, which engages a filtering policy, which is set by the NSA, to allow you to send and or receive that data from one network to another. Next slide. We have two solutions that are used in some of these cases, the XD Bridge and the XD Guardian. The XD Bridge is a cross-domain solution accredited by the NSA that is used on the U.S. Department of Defense only type capable connections. And the U.S. Guardian is actually approved as a cross-domain solution for what I'll say is a FMS or a foreign military service connection that might be coming in and out of some of those networks inside that SCIF. So that cross-domain solution, those two cross-domain solutions are really designed and tested by the United States government. It's led by the NSA and the NCDSMO for the accreditation factor for those data type transfers that need to take place. That may include a file transfer, a UDP packet of sensor information that may need to be shared, and or a video. In some cases, this is mission data. In some cases, this is just data coming from one network to another. And what's important here is you have both a unidirectional and bidirectional transfer capability for that dimension. The data sets that we're talking about here can vary, but most part we have protocols that can address all of them in the DoD space. Next slide. We're at questions, so that's perfect.
For our questions portion, I see the chat's kind of have some comments come in. Brian, do you want to go ahead and tell us about some of the questions?
Yeah, so we've got a question that's asking, so does UFC 41006 apply to ESPC or US ESC projects? I think, Eric, could you comment on that?
So the two acronyms, what was the two acronyms again, Brian?
ESPC or UESC. So ESPC, I believe, is about environmental impact on buildings. So I think they're asking about these specific types of projects. Yeah, so the clarification about ESPC, energy savings.
Okay, yeah, that's a good question. And really with other federal agencies outside DoD, we have seen it more and more common to require things and using almost UFC as a baseline. So understanding up front what the scope of the project is, this is definitely, like I said, by executive order, was directing even federal agencies to include more of these on your projects and more of these requirements. It is an evolving thing. Cybersecurity constantly is changing, and the requirements for those are changing. So right now, the requirements, UFC is almost used as a baseline. But I would see more of those federal agencies coming out with kind of their own things. GSA has definitely gone more to this UFC, so we've dealt with that on that side as well. So I would say they probably are applicable, and you just need to talk with your contracting officer to see, how that's going to be incorporated into your project. But we are seeing it required more and more on other federal agencies, just not DoD.
Right. So I'd say it depends on the environment where the project's being done and the department that oversees it. Yep. So we also have a question, do the project-specific needs get vetted out during design phases A and B? during the review periods by the client team?
Okay. Yes, so the requirements all should be done during those stages. So early on, again, the UFC 41006, Chapter 5 will go through each stage and kind of what needs to be done during those stages. And again, it's kind of got to be tailored to your project, and your consultants hopefully kind of have a little background on what those requirements are, because the UFC is more, overall big picture, what do projects really require. But tailoring those to your projects may be required. But yes, each of those steps, you're going to need to make sure that you have this included. Because like I said, it is a requirement specifically on DoD projects.
Mm-hmm. Okay, we also have a question asking, how do you keep security on the control systems through the bid and construction process if the contractor chooses different control systems than the one you originally designed? And I think part of this answer is going to be common protocols. So you might be able to swap out one control system for another, but if the baseline control protocols are the same, then the security features can be added as a layer on top of the control system. So they can be separated. And I think it comes down to requirements. So if you specify the security properties that are required, then yeah, you might have some flexibility in which specific control systems you use, but you still have to meet the same security properties. So again, I think you can separate those out. Eric, does that match your experience?
Great explanation for it, Brian. That is definitely what we've seen, because as government definitely doesn't allow proprietary things going out there, as criteria and performance specs are getting more and more common for how we lay things out. So Brian, how you described it's perfect. That's what we're seeing is you can't necessarily flat spec some things. There are some people that do get some letters because of HVAC controls and some other systems, fire alarms, another one we've seen. But a lot of times what we do now is, especially with core projects, you have to, open it up. You can't just put a proprietary name on things. So we give those performance specifications and criteria that they still have to meet. So if an existing building has one system, sometimes they can get some waivers, but most of the time we're going to leave it open and just say you have to meet these performance specifications, and if not, you just don't qualify, but we leave it open so you can have multiple bidders.
Great. And another question, are all OWL Traces products exportable outside the US? So the simple answer to that is no, they're not all exportable. So products that are certified for cross-domain solutions by the NSA for use in domestic applications, once they're used in a sort of top secret or classified environment domestically, then they no longer can be exported. Right? There's a concern about foreign attackers getting access to these systems and using them to practice or learn how the filters work. Therefore, once they're used in one of those environments, they can no longer be exported. That is why one of the examples that Anthony gave was he mentioned a product called XD Bridge and another product called XD Guardian. And we've actually implemented those using functionally equivalent, but different implementations of the filter algorithms, such that the XD Guardian product is exportable and the XD Bridge is not. So we actually have that option that you get equivalent product, equivalent functionality, very similar setup and operational requirements, but we have a version that is explicitly exportable. And going forward, we're trying to maintain that parity so that we always have a domestic version that is controlled and regulated, and then a separate exportable version. Another question is asking, does the electronic security spec require an integrator to be available from the vendor throughout the shop drawing installation and startup of the system? Not sure how to address that. I'm not sure what they mean by an integrator. Is there some clarity you can bring, Eric?
Yeah, I mean, where I'm thinking they're kind of going with that is delegated design pieces. So again, since we list performance requirements, what the systems have to meet, it is an integrated thing with those other systems. So someone coming in doing your cyber protection may not be the same person that's installing your card readers, but they need to be working together and collaborating to make sure the systems work together. So yes, during the whole shop drawing process, where the person doing card readers, door hardware, things like that, need to be engaging with that other sub that's doing the cybersecurity piece. So having those work together, making sure the shop drawings are coordinated, does need to be followed through. So that's a great question and a great thing to watch out for in your projects, is making sure that teams are working together and those subs are working together.
Okay.
So
another question of high interest is, does the inclusion of these requirements affect the project cost and timeline? And do you have any rules of thumb or guidelines on how it might impact cost and timeline?
Most things with construction and design, the earlier you get it, the least cost, the least schedule impacts are going to be done. So yes, cost will go up by having cybersecurity requirements, but if you can understand exactly what's going to be required, you can kind of go ahead and budget that into your project to where down the road during a VE, you're not having to VE something out in order to accommodate these cyber requirements. So it does increase your project some, but understanding early on how that's going to help with security and mitigation of those requirements will definitely lessen that impact for cost and scope on your project.
Great. Another question, are we seeing similar requirements listed for this UFC for non-DoD projects? And from the OWL side, I can say that we don't see references specifically to UFC 4.10.06, but we have seen a significant uptick in interest in the types of security capabilities we bring for non-DoD projects, where people are just recognizing that building automation systems, connected buildings, are a potential threat, particularly if those building automation systems are bridging between their internal IT network and any external service providers or cloud applications where they're doing analytics. So we've seen a significant increase in the types of capabilities we bring, the types of things that Anthony had explained for non-DoD applications. Eric, on the pond side, do you guys see specific references to the UFC for non-DoD applications?
Yes, that's kind of went back to the first question is, it started with DoD, and we've seen it with other federal agencies. Like I said, GSA is one I mentioned. It's becoming more and more of a requirement we're seeing as the cyber side is protection and how can we protect. And again, as it's evolving, UFC is a great baseline to start with, and I think that's why a lot of other federal agencies are pointing to it. A lot of agencies, have those ICD 705 spaces, have those more secure spaces. So knowing how they can protect those, and we're trying to understand how they can protect those, because we, a lot of times we point back to the UFC. So yeah, we're seeing it more and more, like you said, an uptick definitely, especially as we're seeing more secure spaces in office buildings even. So it's definitely seen an uptick.
I think, Eric, you're absolutely spot on. The details of some of the other critical infrastructure market that Brian was alluding to also has other compliance efforts that talk about data diode technology, including NERC-CIP, which is Nuclear Energy Regulatory Committee, which is talking about nuclear power facilities, things to that nature, and also looking at how just in detection for national assets, as much as you think that items just industrial control systems, they're considered national threats as well, so you have to be careful about how you're protecting them.
Anthony, you talked a little bit about removable media or portable media like USB drives, CD-ROMs. Could you give a little more detail on a use case where somebody might be bringing media into a room? And I'm thinking specifically of there's distinct use cases between bringing in media, say, for a presentation or something like that, versus something as an update to an HVAC system. So would the technology you described be applicable to both of those use cases?
Have the ability of, in some cases where you're protecting the media coming in, that USB drive is actually a vulnerable threat because you don't know what capability, in some cases, you could pick up a USB drive at a trade show and think that it's just going to have the files and a PowerPoint presentation on there from Pond or OWL Cyber Defense. You just putting that into your network is a vulnerability in itself. When you talk about updating from an HVAC perspective and updating the software capability that's there, before you do so, you need to do a deep content inspection to make sure that there's no vulnerable threat to that update prior to making that happen. That's a very important element here, as bringing in just a CD or a DVD-ROM that might have provide that update to the system itself.
Okay. Another question around cost and planning. So how do you make sure that you actually capture the cost when planning or developing a design and build RFP? I think that's a question over for Eric.
Okay. Yeah. So, we kind of talked about it is, the start of this, step one is identifying everything that needs to be secured on the cybersecurity side. That was the step one of the 5-step process. And during that, you're going to and that's done during the planning stage. So during the planning, if you can lay out what those requirements are, it's going to be very helpful to you. And then it'll also be able to give you some associated costs with that. For the design build side, again, the UFC does go through some things that have, the 15% level, 35% level. Oh, sorry. Can you guys hear me?
I can hear you now. It sounded like you dropped out early on in the response. If you could just give a quick summary of what you were saying there.
Yep, sorry. Technology, probably something happened there. So yeah, during the planning, and especially, design build, RFP stage as well, you're not going to go through full design, but you want to make sure you capture things in the criteria, performance requirements accurately, and that's going to help your cost estimators determine what costs you need to carry into your project. So laying those out early, and why step one is so important, and you can't move on to another step, is making sure you have all those ironed out up front. And you can put some associated costs with those to anticipate for your projects.
Great. There's a question earlier. Somebody was asking, will there be any continuing education credits associated with this class? I think the answer to that is no. I don't think this is counts for anything in particular. Also, another quick question: how can you bring teams on board to help with projects? So how do you get started? How do you get engaged? How do you start this process of doing a security relevant project?
Sells contact information. For the pond side, again, full service AE firm with master planning, military planning, construction side. So we can, be on board for all that. We have contracts with most federal agencies, most DoD, Corps of Engineers, to where, if you have projects, we can definitely open to talk to you about it and find a contract vehicle to execute those. So that's really how most of our projects get started is, love to talk to you, love to hear from you guys on projects you have upcoming and give you solutions and how we can help you. And like I said, is we can probably find a way to get to you and your projects to help you with those.
Great. And are we going to be able to make a version of this video available for playback later? Is there a link that we'll be able to send out? Oh, didn't catch that response. I think the answer is yes. I just want to confirm.
Answer is yes. We will make this available. So all registers will have this link sent to them. So yes, if you were registered for this, you'll be able to get the link for this and be able to watch it later on. Great.
I think that's all I've got in terms of questions. I would like to just add that, I think this is an exciting opportunity. So Pond has deep expertise in the design, the project management of these types of secure facilities. And on OWL, on our side, we have historically focused on data isolation and data segmentation, data security. Bringing the two capabilities together is a really powerful combination, especially as you see deeper integration, particularly in the building automation and building integration into both building networks and to security of critical applications. So the UFC document describes the detail how to do the analysis and assessment of that. Here you're seeing side by side the technologies and the capabilities, the process, and the solutions that you need to realize those requirements. And I think it opens up some new possibilities for deeper integration, maybe connectivity, new services, and new features that weren't available before. So you can offer upgraded monitoring and health status checks on building equipment, building status that weren't available before safely through the proper security controls and mitigation technologies. So from the OWL side, we are excited to work together to make that possible. Eric, give any closing comments on your side?
Oh, I appreciate everybody's time. Brian and Anthony, I definitely appreciate you guys being on with me today. Glad to do these, reaching out to you guys and users on the phone. If, again, any way we can help, or if you have any further questions, you can definitely reach either of us by email or phone, and look forward to getting started any projects you guys have. So thank you.
Great. Thank you.